Hi ladies, in this video we're going to go through the more challenging questions of 7E. So 7E being two-step experiments using tables. So we're looking at questions with replacement and without replacement, and they're not always going to use the words with replacement and without replacement. So you need to know when they're asking for replacement and when they're asking without replacement. Okay, so this question here, we've got 10 students who completed a special flying course are waiting to see if they will be awarded the one distinction or the one merit award for their efforts. So there's only one of each given. So in how many ways can the two awards be given if the same student can receive both awards and the same student cannot receive both awards? So we're looking at how many ways. Now, I did this question earlier and I wasn't actually recording, so I've kept this table up just to explain how to do your table. Now, I won't be talking through it as I do it, but I'll explain what it is. So we've got the distinction award. This distinction award could be given to student 1, student 2, student 3, and so on. So these are all people: Mary, Bob, Steve, John, whoever. And then the merit award can be given to, Mary, Bob, John, Steve, whatever names I'd given them. So in this cell here, 1-1 means that Mary got both the distinction and the merit award. In this cell here, if I was 1-2, that means Mary got the distinction award and Bob got the merit award. Okay, and so on. So the number of possible outcomes is 10 by 10. So there's 100 ways the awards could be given. Now, if we're looking at the second part of this question, which is the same student cannot receive awards, means that it's without replacement. So basically, a student can't have a distinction and a merit. So, sorry, Mary, you can't have both. And Bob, you can't have both. And John, you can't have both. So basically, we're crossing out down the diagonal, and there's going to be 10 outcomes that you can't have. So the second part of that question is 90. So 100 if you can have students get both awards, and 90 if they can only get one award. All right, moving on to question B. So assuming that a student cannot receive both awards, find the probability that a particular student receives the distinction award. So let's focus on Mary. So I'm going to just fill in Mary's column. So you can see the pattern here. I won't keep going actually because I've run out of room. But Mary obviously can't have this first option. So she's only left with 9 other options. So and every student's going to be the same. So the probability of getting a distinction is going to be 9 out of 90. So she's got 9 possible chances. So she can get the distinction and Bob gets the merit. She can get the distinction and John gets the merit. She can get the distinction and Steve gets the merit. So 9 out of 90, which is a probability of 1/10. Okay, the merit award, so it's going to be the same thing. So the probability of a merit is also going to be 1/10. And neither award is, okay, so the probability of not a distinction or a merit is sometimes easier to take away what you don't want. So we don't want a distinction or a merit, so it's going to be 1 minus the probability of a distinction minus the probability of getting a merit. So 1 minus 2 on 10 gives you 8 on 10, which is 4/5. Okay, so the probability of not getting an award is 4 out of 5. Assuming that a student can receive both awards, find the probability that they receive at least one award. Okay, so it's a little bit harder. So, actually, no, it's not that harder. So we already know it's out of 100. So we want the probability of of D or M. And this time it's out of 100. Now it's slightly different to this one because we were doing the probability out of 90. This time it's the probability out of 100. So if we look at Mary, if we went down the distinction, there's 10 opportunities that she can get that. So I'm just going to add them up here, 10. And if she got a merit, there's 10 also. So plus 10. But in that 10, I've counted the 1 twice, so I need to take away 1. Okay, so there's 10 possibilities for her having a distinction, 10 possibilities for her having a merit, but when I've added them together, I've added the 1 twice. So I've just got to subtract that 1. So 10 plus 10 is 20, minus 1 is 19. So the probability is 19 over 100. All right, question 8. 2 fair 4-sided die are rolled and the sum is noted. Find the probability of the sum of 5, a sum less than 6. So we've got 2 separate dice. So the first die, sorry. Second die. So we can have a 1, 2, 3, 4. And the second die is 1, 2, 3, 4. So we're going to add them together. So 1 plus 1 is 2. So you can just, this is very similar to a question we did before. 3, 4, 5, 6, 7, 5, 6, 7, 8. Find the probability of a sum of 5. So the probability sum of 5. So we've got 1, 2, 3, 4. So 4 out of 16 possible outcomes. So a quarter. So 16 because it's a 4 by 4 table. Now the second part, probability a sum less than 6. So less than 6, we're not including 6. So sometimes it's easier to take away what you don't want. So we've got 1, 2, 3, 4, 5, 6. So that leaves us with 10 over 16. And that is 5 over 8. Find the probability of a sum of 5, given that the sum is less than 6. All right, so what I might do is just use a different color. So we want the probability of a sum of 5 given that the sum is less than 6. So if we look at all the ones that are less than 6, okay, and you can use your conditional probability formula for this as well. So less than 6, we have 10. So your probability is going to be out of 10. And how many of them are 5s? We've got 1, 2, 3, 4. So that's going to be 2 over 5. Now your conditional probability formula, I should have written it like this. The probability sum of 5, so probability of the sum is 5 given that it is less than 6. Okay, so conditional probability formula, the probability of 5 and less than 6. And I always do that, I write the probability, but you can just write the number. Over the number that is less than 6. Okay, so 5 and less than 6, there were 4 numbers. Number that is less than 6 is 10. So using your conditional probability formula. All right, so you can do the same thing for question 2 and question 3. So just using your conditional probability formula from the previous chapters. All right, question 10. In a game of chance, 6 cards numbered 1 to 6 are lying face down on a table. 2 cards are selected without replacement, so we want without replacement, and the sum of both numbers is noted. State the total number of outcomes. So it's a 6 by 6 table, but we're subtracting the diagonal, which has 6 numbers. So 6 by 6 is 36, take away 6 gives you 30. Find the probability that the total sum equals to 3. So you can do your table, okay? All right, ladies, I'm sorry, but my my computer just died on me, so I'm going to have to start question 10 again. I probably should have edited it and started it from start of question 10. But anyway, we did make some progress, but I'm going to have to write it again because everything shut down. But I was glad that the video actually was saving as it was recording, which is good. Okay, so we're looking at 6 cards lying face down on a table. 2 cards are selected without replacement, and the sum of the total numbers of both numbers is noted. Oh my gosh, I can't talk properly. All right, I feel like I've done so much thinking this morning doing these questions that, yeah, I feel like I'm not making much sense sometimes. Okay, so these are our cards. Now we're doing it without replacement, so we can't have anything along the diagonal. So in total, we had 36 numbers, but we don't want what is down the diagonal, so we're subtracting 6. So we have 30 possible outcomes. Find the probability that the total sum is equal to 3, equal to 4, at least 10, no more than 5. So it's kind of getting used to those numbers. So the probability of 3, now you could go on and fill in this complete table, but it's quite time consuming. So I'm just going to fill it in as we need to. So we've only got 2 numbers that can have a total of 3. So 2 out of 30, which gives you 1 over 15. And I'm just checking that I did need to do the probability. Okay, so sometimes it says the number. This time it's the probability equal to 4. So the probability that we get a 4. Okay, so I'll fill in a little bit more of our table. So we can have a 1, 3 and a 3, 1. And we can't really have any more than that. I'm just making sure I'm all good. So we can have 2 out of 30 again, which is 1 over 15. All right, the next question, at least 10. So the probability, we want it greater than or equal to 10. So we're kind of looking down here now. So when you think about it, we can have 5 and 6, which gives you 11, and it's symmetrical, so we can do both at the same time. And then we've got 4 and 6, so 10 and 10. So we've got 4 out of 30, which simplifies to 2 over 15. And what's the last one? No more than 5. So no more than 5 means we want less than or equal to 5. So no more than 5. And so we include the 5s. So we want 5, 5, 5, and 5. My table's not the neatest, so it's a bit hard. 1, 2, 3, 4, 5, 6, 7, 8. So 8 out of 30, which simplifies to 4 over 15. All right, what would have been the answer to part B if the experiment had been conducted with replacement? So that basically means we would now have 1, 1, 1, 2, 1, 1, 2, 2, 3, 3, and so on. So, and we're only doing the first one, equal to 3. So we can actually only have 2 possibilities, even if we got rid of the crosses, which I'll do now so you can see. I won't do it for all of them because we're only looking for the number 3. So this would be 2. So 1 and 1 is 2, 2 and 2 is 4. So we still only have 2 options, but because we've now included with replacement, your probability is going to be out of 36. So 2 options out of 36, 1 over 18. So you're decreasing your probability a bit. Okay, that was that question. All right, all done. That was very time consuming and difficult for me to do, girls. I feel like my brain is fried. All right, bye.